All right, so I want to talk about stretching and shrinking. So if you recall, we've talked about this form, y equals a, and then your function x minus h plus k. We're going to be talking about a here in this lesson. So you have your different functions that we've used. It's the same format for each, but it's always good to have in front of you so you have that information and you're practicing how it looks. So I know we have them in a few sections of our notes, but that's always good to write because these are the ones that you see a lot when you're working on this stuff. So we've got all those here. So we're going to be dealing with A, that's your stretching and shrinking. So we talked about this a little bit with our quadratics unit, and I know that was kind of it was all online, so it was a little bit difficult. So you have something with the stretch, the vertical stretch, and then the shrink. So stretching, you can think of like pulling it up like a rubber band. It's getting smaller in width. This is when A is greater than 1. So you have numbers that are bigger than 1 that are pulling your graph super, super thin instead of what you normally start with the parent function. For shrink, it's when you have numbers between 0 and 1. So what that looks like is you have a very wide U shape, like for a quadratic. That's the example I'm using. So it's getting squished towards the x-axis instead of pulling up towards the y-axis. So we're going to practice this a little bit. There is a type of stretching and shrinking that goes in front of this x, but you guys will talk about that in algebra 2. We're not going to focus on that. Okay, that's not something we need to do, but I just wanted you to be aware it is there. So we're going to look at number 1, its absolute value. So I'm going to use my parent function, like I always do. Graph my parent function first. You should always do that. So you're graphing your parent function. Okay, so y equals absolute value of x. And we have a transformation we have to do in addition to our a value that we have here. So now we have a number for a. So if you look, we have an h. This h we're going to do first, and we'll do a complete list of order and all that stuff in one of our notes coming up. We have an h, we'll do that first. It's plus, so that means we're going to go left 6, and we're going to go left 6 first. So 1, 2, 3, 4, 5, 6, and then all of my points follow. And again, this is not my final, so I'm going to leave it as dotted. Okay, but it's very important that your points are accurate here because I want to show you how this next step works. So here we have an a value that's equal to 2. So we should have what they call a vertical stretch. Okay, vertical stretch. So with a vertical stretch, it affects the math that you do in here at this point. So we're gonna do a table so you can see what that looks like. Okay, so over here where it's not in the way, okay, these are the x values I'm going to use because that's where I'm at. So 1, 2, 3, 4, 5, 6. Okay, and then I should have -5, -4. I'm going to do -7, -8, because it is symmetrical. I want to make sure that I have the right numbers. So when I add 6, I get 0, I get 1, I get 2, and I should get 1 and 2 here as well. But then I have to take this y column, because that's what's highlighted is what we just did, we need to take that and multiply those by 2. Okay, so we're going to take all of these numbers and we're going to multiply them by 2. So when we multiply them by 2, because that's what we've simplified in the absolute value, we get 0, 2, 4, 2, and 4. So this 0, 0 or negative 6, 0 stays the same, but this negative 5 moves up to this 2, and so will the negative 7, and then the negative 4 will move up to 4, so 1, 2, 3, 4, and then that's our final, so you can kind of see that shape change. Okay, it's pulling it up more, it's squishing it so it's thinner. Okay, and that's our final graph here. So when you have an a that's greater than 1, that's what that's going to do. Okay, so I want to go over here and look at number 2. It is a parabola, so it is a quadratic, and it's kind of using different notation. So we have this function, this is f of x, and they're telling us that we need to create a new function, and the new function is going to be equal to 1/2 of f of x, the one we started with. Okay, so we have these points, we have the equation, but we have these points that they gave us, so we can use those. So when we make a table, when they're giving us points, we don't have to create vertex form, we don't have to do anything like that. If they're giving us the graph itself, we can look for the points that they're giving us and go from there. So I have x values of -3, -2, -1, 0, and 1. And the y values that go along with that are 0, 3, 4, 3, and 0. But now that's the original function. So now our new function, using the same x values that we had, it needs to be half of what it is. So this is our original, and this is going to be our new. And so we know that half of 0 is 0, half of 3 is 3/2, half of 4 is 2, half of 3 is 3/2, and half of 0 is 0. So when we graph this new one, we still have these. I'll use my bright color. So this -3 and 1 are the same, but the points in between change. So this -1, 2 in particular, where the maximum is, your maximum changes drastically. So then -2 and 3/2, and then your y-intercept changes to 3/2. So it's flattening out your function and making your units, your output smaller. Okay, so that's when you have an a. This would be your a is between 0 and 1. Okay, so let's take a look at, let's do a quadratic, another quadratic. We've got number 3. So we have a few transformations with it. I'm going to do my parent function real quick so I know what points are moving when. Okay, so y equals x squared. So I have an h, I have my a, and I have a k. And we've always had an a, but it's always been 1. Now it's something else. So my h here is my left, right. So I'm going to go right 1, and I'm going to document all of my changes so I can keep track of where I'm going. So I'm going to move all these points to the right one and do my graph as a dotted line. I have a equal to 3, so that's going to be a vertical stretch. Okay, so I'm going to change some of these points. This is the order you're going to do it in. Sorry, backtracking a little bit. This is the order that you'll do it in. Again, we'll do a final list when we get there. So a lot of these points are going to change, like the output's going to change. So I'm going to do my table. I need to do 3 times whatever my output was at this step. So I have x values of -2, -1, 0, 1, 2. Oh, no, that's not right. Sorry, I'm looking at the wrong one. -1, 0, 1, 2, and 3. Okay. My vertex is 1, 0. So 3 times 0 is 0. But -1, what is it? -1, originally it has an output of 1, 2, 3, +4. 4 times 3 is 12. If I input 0, I get an output of 1. So 1 times 3 is 3. And same with, we already did this one, 0 times 3 is 0. 2, 1, I would get an output of 1, but now I have to multiply that by 3. I get 3. 1 times 3 is 3. And then same thing here. I have 4, and I need to multiply that by 3, and I get 12. So there's only so many of these that I can actually graph. So I'm going to graph what I can. So 1, 2, 3, and then 1, 2, 3. And then again, this is not my final. And you see how it kind of pulls up? You're pulling kind of inside and up for this. So now the last thing that you'll do for the transformations at this point is you're going to take care of your K, which is your up or down. And here we're going to take all these and go down 6. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And remember, we're using the green one. 1, 2, 3, 4, 5, 6. No, and we could graph these ones now if we wanted to, but we're all right. So this is your final right here. This is what it looks like. If my tablet will let me write final. Okay. We have just enough time. Let's do one more. We'll do it real quick. We're going to do the absolute value. So here we have an A that is between 0 and 1. And if you recall, that's a shrink. Okay. So the first thing we're going to do after we graph our parent function is we are going to do our H. So H, remember, is left, right. We're going to go left 6. So 1, 2, 3, 4, 5, 6. And all of your points follow. Okay. And then again, I'm doing a dotted line because it's not my final. So I'm color coding and doing dotted lines so we know which one's which. So then what I'm going to do now is my A. My A is 2/3. So for my table, everything on the inside of my absolute value needs to be multiplied by 2/3. So now I'm just going to use points -8, -7, -6, -5, and -4. I think that should be enough. So -6 is our vertex. 2/3 times 0 is 0. So -8, we get 2, but then we have to multiply that by 2/3, and we get 4/3. And then for -7, we get 1. And we're just going to take all these and we're going to multiply them. So this should also be 1. And that way we get our new shrink so we can graph it. All right, so we have these new points. They're not going to be pretty, but it'll be there. You know, again, it's estimating sometimes. And this is going to be our final graph. So here, and then 2/3 is about there. 4 is 1 1/3. So it's just a little bit above 2/3, 1 1/3. And so it's going to look something like this, okay? And that's our final. So you can kind of see it's flattening out, and that's the shape that shrinking does, okay? So if you have any questions, come see me during office hours.